Okay, so by this point, you should have already watched my video on the sizing of rigid tubing. And this is the page that talks about the sizing of rigid tubing, but I've already gone over that in a previous video. So I'm going to go ahead and advance and use this time to teach you guys about how to cut tube, how to flare tube, how to bend tubes, and then also the difference between the AC and AN fittings. So first of all, when you're cutting rigid tubes, the best tool to use for that is called a tube cutter. The tube cutter is illustrated and used in this picture. To be honest with you, the best way to get familiarized with a tube cutter is actually using it, which we'll do in projects 1, 2, and 3. So you'll get the chance to use those when we get back into the shop and get these shop projects knocked out. But when you cut a tube, always remember that you want to cut it a little longer than the tube you're replacing, so you have room to do your flares and also room for any errors or anything like that. And if you're cutting a harder material, it's not advisable to use a tube cutter. It's best then to use the hacksaw, but the majority of the time you're going to be working with softer materials, you can use a tube cutter. If you're working with harder materials, then you'll have to use a hacksaw. Once you've made the cut, then there's probably going to be a rough edge to it, so you're going to have to do a process called deburring. We do have a tool on campus that will deburr the part for you, but you can also use an X-Acto knife. And on this next slide, it'll kind of show you a picture of basically this is the end of the tube, and what you're trying to do is kind of create a chamfer on the inside and the outside of that to help prevent any stress areas or any cracking when you're getting ready to do your flares. So what's a flare? A flare is a way for the tube to seal to a fitting. There is a tool, there's actually there are 2 different tools that do the flares for us. We have both of them on campus, and you'll get the chance to use both of them. One of them does it all in one tool, and the other one has 2 tools to the one tool. So it's actually 2 separate pieces. So first thing is, before you're going to do a single flare, you still have to cut and deburr the tube, probably using a tubing cutter, and then go ahead and deburr it. And then you're going to use aviation flaring tools. It's important to understand that aviation flares and automotive flares are a little bit different. And if you try and use an automotive flare on a aviation part, it won't seal properly. So the aviation flare is normally 37 degrees, although there are some fittings out there that are 35. The difference is the 37 relates to AN fittings and the 35 AC fittings, and we'll go over that in just a minute. But automotive is a 45-degree flare, and I believe I already asked that in on one of the discussion boards. So this is going to walk you through the process of how to do a flare. Like I said, one of the best ways to learn is to watch the YouTube video I posted on that. And the guy does a demonstration there on how to do a flare. And then once you're done with the flare, you're going to be checking it for these different things. The size of the flare, which you use a micrometer or caliper for, out of roundness, smoothness, straightness, cracks, and so forth. So I'm going to go to the next slide so you can see what a single flare looks like. So it basically takes the tube here and kind of makes it go out like that. So that way a fitting comes down in here and it'll seal. When I say a fitting goes down there, I'm going to skip a few slides to show you what I'm talking about. So if you notice all the ends of these fittings, they all kind of have that same flare to them. So that way the end of the tube, it would fit on and go right on to any of these fittings. And that's where it actually seals. So that's what a flare is. The size of the flare and all that's super important. But these are called single flares, and that's what you're going to use most of the time. Sorry, let me go right here. You're going to use a single flare, and that's the 37 degree. So if you were to go straight from here to here, that angle would be a 37 degree, and that's the most common, although there are some aviation fittings that are 35, and then their automotive is the 45. So then sometimes you might be doing a double flare. What a double flare is, it takes a special tool, and you're actually going to take and make a regular flare first. And then what it's going to do is take this and bend it over so it thickens this area right here and makes it a lot stronger and prevents from shearing effect. The only problem is it's difficult to do on hard tubes and larger size tubes. So it's only recommended on, it'll say right here, 3/8 or smaller tube, softer aluminum alloy. And again, its purpose is to prevent the shearing effect. So if somebody was to trip over the line or bump the line with their elbow, it would be less likely to break if it was a double flare than a single flare on a weak tube. So it's mainly used on the weaker tubes. So double flare, 37 degrees still, but it's done again with a specialty tool. I do have a video I'm going to post about that for today. on a double flare, and that way you can have seen the difference between a single flare and a double flare. Okay, the last thing I wanted to cover real quick on this video, let me get to it. There's the double flare tool. We have that's the double flare tool, that's the tube cutter, and that's the deburr tool. So this is double flare, tube cutter, deburr tool. I want to talk about tube bending. And then I'm going to put a later video on the calculation on the way to check to make sure that the tube bending is correct. But for right now, tube bending, typically it's going to be done with a special bender. And there's a video I posted on the YouTube or the video section on this class. Make sure you watch that on how to do a bend. But usually you want to put a bend in a line because a bend alleviates stress. And there's a question about that on the quiz and on the worksheet. But you want to make sure you use a proper size bender. Make sure you don't get flattening, smoothness, or make sure it doesn't get flattened. It stays smooth and it doesn't have any kinks or wrinkles in it. And you're normally going to get a little bit of flattening just through the process of bending. And that flattening is going to normally occur kind of back here. And there's a formula to figure out. But you have to maintain 75% of the original outside diameter on a bend. Basically, another way of looking at that is you're allowed to have 25% flattening on that bend. And we're going to do a calculation on that tomorrow. It's not on today's quiz, so I'm not going to worry about it today. But tomorrow I'm going to teach you guys how to do that calculation. This is what the tube bender looks like. It's pretty easy to use, and once you've used it a few times, it's not too difficult. And you'll get the chance to do that on Project 3. On Project 3, we're going to be doing 2 bends. All right, now last thing I wanted to cover today is the difference between AC and AN fittings. Because a bunch of you on the discussion board, and I asked what's the difference between an aircraft fitting and an automotive, the flare angle, a lot of you mentioned that 35 degree. You're technically right. 35 is an aircraft fitting, and so is a 37. But 37 is going to be the most common because there's Air Force AN that we're already familiar with. You're probably not as familiar with AC, which is Air Corps. Neither am I, because you don't see them very often because they're used on mostly older type aircraft. I'm going to show you the difference between an AN and an AC here in just a second. Actually, I'll go there right now. There's a slide right here. This slide is the easiest way to summarize the difference between an AN fitting and an AC fitting. And the bigger difference is this is a 37 on a degree flare on an AN fitting, and the AC is a 35 degree fitting. Also, this one has a shoulder or a recessed area where there's no threads. This is threads all the way to the flare cone. It's a little bit longer on the AN fitting than the AC fitting, and the threads are a little bit different. They're a little coarser on the AN fitting than the AC fitting. The last thing I wanted to cover before we close out this video is that fittings in aircraft, they're color-coded to let you know composition of what they are. So, for example, if I came across a blue fitting, I know it's an AN fitting, and it's made out of aluminum. If I come across a black fitting, it's an AN fitting. I know it's made out of steel. And if I come across a silver fitting, then it's a stainless steel or a CRS. Where on the old AC fittings, they used gray or yellow to determine if it was an aluminum fitting. So anyways, that's just the quick things I wanted to go over in this video because it's kind of harder to understand this type of information. The rest of it is pretty straightforward reading. So make sure you read what I put there for today. And I'll go ahead and post the video on the double flare so you can see the difference between the single flare and the double flare. All right, hope you guys are staying safe. Be careful. Wash your hands. Thank you.